Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the different types of faults that causes different types of earthquake. So in detail, we are going to understand what are these various types of fault, how they differ from each other, where they are found, which kind of area in the world they are found, and also how they impact the overall geological process. So first of all, to give you the background about this particular topic, the fault, the term that is basically refers to a fracture, a big large fracture that develops over more than kilometers of range in the rock system, where there has movement and also displacement along the rock structures. And when talking about the earthquake being along the fault lines, basically when you talk about fault, it lies at the major plate boundaries. As we know that Earth, the lithospheric part of the Earth, the upper part of the Earth is divided into various different tectonic plates which consist of crust and upper part of the mantle. So basically we try to understand, as we can see from this particular map, we have different types of plate here. For example, we have Pacific plate, which is an example of oceanic plate. We have Australian plate, Eurasian plate, Arabian plate, and all the plates, as you can see, if you mark the boundary, the bold black line that you are seeing here, they demarcate the boundary zone between two different type of plate. And plates are not static, they keep on moving from one place to another place, and that is why we see a relative motion between two different plates on the world or in the world, and it is due to this relative motion we see the development of the fault that we just have talked about. And whenever there is a movement of fault, whenever there is a disturbance along the fault line, we see the resultant impact that earthquake is generated, as it has happened few weeks back in the Turkey. Now plates are something that is slowly, they can move very slowly with respect to each other, or they can keep on moving continuously against each other, and in this process they build up stress in their structure. And suddenly when the rocks move, this stress is released up. Suddenly there is a kind of jerk that is observed along the plate boundary, and this release of stress is basically the energy that is released is transmitted, actually is transported through or in the form of seismic wave, which when reaches the earth's surface causes violent shaking of the earth's surface and the structures above it, and that is what leads to the earthquake and the damages that is caused by it. So most of the earth that we see happening across the world are caused by not continuous or gradual movement, but very sudden movement along the fault line when the stress is built up. Now, to understand, there are several other terms that is related to the fault. For example, one term that we come across whenever there is a news about earthquake is fault plane. So, what is a fault plane? Now, fault plane can be simply defined as a flat surface that may be either vertical in nature or sloping in nature, and the line that makes the fault plane on the Earth's surface is called as fault trace. Second term that is used with respect to fault is hanging wall and footwall. Now, wherever the fault plane is sloping, as with normal fault or reverse fault, both we are going to discuss in coming times. So, wherever we have the fault plane that is having a sloping kind of a structure, basically we can divide the entire fault plane into two parts. One is the hanging wall, that is upper side from the fault plane, and other is the footwall, that is the lower side of the fault plane. If you look at the diagram here, you can clearly see that this is our fault plane, because this is the area along which you have the movement of two different rock systems. And this we can see from the diagram. This part of the landmass, this part of the plate seems to be hanging above this particular downfolded part. So that is why in this diagram, this will be example of hanging wall block, while this will be an example of, as we have discussed, footwall block. The third important term that we come across when you're talking about fault is strike and dip. Now, a strike is something that determines, that basically tells us about the relative motion of the plates, how it is happening across the fault. So the strike is basically the direction of the fault trace on the Earth's surface. Fault trace we just have discussed is the line that fault plane makes on the Earth's surface, and the direction of this line, how this line is being made up due to the movement of the plate, is what we can call as a strike. On the other hand, dip basically gives us the idea about how steeper is the fault plane. Now let us go again and look at this diagram here. So as you can see, this part of the line, this part of fault trace where the movement is happening is what is referred by strike, and then dip is like whenever any two different rock systems are there, two different plates are there, when they are moving with respect to each other in upward or downward direction, or due to this we have development of a slope. So the steepness of the slope is measured by the dip. Now coming to the main topic, that what are the different types of fault we find across on the earth. So first of all, we have normal fault. Now, if you look at this diagram, we can clearly see that what is happening here, that the surrounding blocks are maintaining their position, and this central rock block basically has fallen below. It has gone down below with respect to this first block and the second block. So whenever the hanging wall drops down in relation to the footwall, this kind of fault is called as normal fault. Normal fault basically is developed due to the extensional forces. Extensional forces means the forces that is pulling these two part of the plates into opposite direction, and as a result of this the central part start to move in the downward direction. And the reason why it is called as normal, it is not because this is the most common type of fault we find, but the normal term has been derived from the logic that in this kind of motion basically the movement of plate is following the gravitational pull, that is a natural force exerted by the earth's surface, and that is why it is seen to be going in the normal direction as far as the gravitational force is concerned. So it is due to this reason this fault is called as the normal fault. Now basically these kind of faults develop in those areas where we are having continental divergence. Whenever you have continental divergence, that means we have two continental plate. For example, this in this diagram we can consider it as C1, that is continental plate 1, and C2 continental plate 2. And due to the forces coming from below the Earth's surface, due to the convection current that is flowing below the lithospheric slab, lithospheric layer, these two continental plates are pulled away, leaving behind the central part to fall in the downward direction. And the best example of this we can see in the East Africa, where you have development of this rift system. Now, obviously, because the central part is going in downward direction, a valley-like feature develops, which is called as Rift Valley. So, all along the eastern African coast, you have a follow valley of Rift Valley kind of system, where the two parts of African plate is being pulled into opposite direction. The western part, which is also referred as eastern part, which is also referred as Nubian plate, is being pulled in the eastward direction, while the major African plate, the main African plate, is being pulled in the westward direction. The similar kind of example we can also see in the Sierra Nevada ranges of United States of America, where also the central California plate or central valley of California is moving in the opposite direction, while on the other side the landmass is moving in the different direction, giving rise to a fault and ridge and valley kind of topography, or mountain or valley kind of topography. So these are the two best examples of our normal fault. The second fault that we see across the plate boundaries are what we refer as reverse fault. And as clear from the term itself, it is just opposite of what a normal fault looks like. That means in normal fault, the movement of the central wall or the central part of the plate was happening in the downward direction. Here, on the other hand, hanging wall moves in the upward direction with respect to the footwall. And as we can see from this particular diagram, this is our footwall and this is our hanging wall. And the movement is happening in such a manner that hanging wall is moving along this plane in the upward direction. And this generally happens when the compressional forces are being exerted on two parts of the plate. And due to this compressional forces, one part of plate breaks down and start to move slightly in the upward direction. This type of fault is also been called as dip slip faults. These are basically reverse fault or normal fault also can be considered example of dip slip fault, because the slope, the fault plane slope that develops here are not vertical but are slightly tilted or sloping in nature or steep in nature. The best example of such kind of fault, reverse fault, we can see in those areas where two different plates are converging with each other. And the most important in the is when we have most, we can say, common is along the continental convergence boundaries, where two different plates coming from two different directions are converging with each other, are pushing against each other, leading to development of a reverse fault. And the best example of this we can see is the movement of Indian plate that is still going on against the Eurasian plate in the north. And due to this, what happens near the collision zone, near the collision boundary, the plates or the rocks of the plate has slightly moved in the upward direction, and the other part of the plate has moved slightly, relatively obviously, in the downward direction. And this is the most disastrous kind of zone, as you can see that is where we have the formation of Himalayas, because obviously any kind of stress that is released due to the break in the rocks or due to sudden jerking movement of the plate can cause significant magnitude of earthquake, causing loss of life to large number of people, because obviously this area of India is highly populated, densely populated region. The third type of fault which we have to understand about is strike slip fault. Now, in a strike slip fault, there is neither upward nor downward movement of the hanging wall or the footwall. Rather, the walls that move in the sideways direction, that is what we can call as the strike slip fault. And as clearly we can see from this particular diagram, here if you consider this can be our plate 1, this can be our plate 2. And plate 1 and plate 2 are neither moving up or down with respect to each other, but they are simply sliding past each other along this common boundary that you can see. And that is when the sliding happens, the rocks along this common boundary gets distorted, gets disturbed, gets broken, and causes the seismic wave generation. In this case, if actually look at the fault plane is usually vertical, so there is no hanging wall or footwall at all. And largely this happened due to the lateral horizontal forces which carry the two parts of the rocks or two part of plate sideways with respect to each other. And this is where you will see the continental transform plate interaction. That is where you have development of strike slip fault. Continental transform plate interaction or also what we can call is as a transverse plate interaction. And the most common example of this we see along the San Andreas Fault region in the western coast of United States of America, where on one side you have the California plate, which is part of the Pacific plate, moving in the northward direction. And on the other hand, you have the continental plate of North America that is moving in the southward direction. And due to this relative northward and southward movement, what happens along this entire region, the rocks are getting disturbed and that causes break in the rock, leading to development of earthquake. If you look at the aerial photo of the San Andreas Fault, this is how it looked like. On this side, we have the California plate. On this side, we have the North American plate. And you can see the movement of plate is happening around this area because here you can see the displacement of rocks are clearly or is clearly visible. The fourth and the last type of fault we have to talk about is oblique fault. Now, oblique fault are most common one because here we have both dip slip actions and the strike slip actions are observed. What we are trying to say here is that here the movement of the plates happen in vertical direction with respect to each other, and at the same time in some places also the movement is observed in the horizontal direction or lateral direction. So when we have combination of both lateral as well as vertical movement, as we can clearly see from this particular diagram, this is what we can refer as oblique fault, and similar extent of motion is basically observed along the oblique fault. That means if vertically plate is moving by 5 meter or 10 meter and horizontally it is moving a few centimeters, that cannot be considered as an oblique fault. The relative motion in both vertical and horizontal direction should be similar in magnitude, and that is when we can consider this fault as a oblique fault. Now, fault and understanding of fault, the study of faults, especially for seismologists, geographers, geologists, becomes very, very important because the faults also reflect the kind of tectonic forces that are acting or are active in that particular area, in that specific area. Whether it is a kind of divergent forces, whether it is a convergent process of forces, or whether it is transform process or transform forces, that can only be understood if we study the plates or the faults of that particular region. And once we understand the fault, it also helps the scientist in preparing a earthquake zone map. That means they can classify that which part of a region, which part of a country is more prone to earthquake and which part of the country is less prone to earthquake and is more safer. And after earthquake zoning is done, it will also help in management of disaster related to earthquake if it happens in the future. So I hope you understood about this particular topic, about the different types of faults, fault planes, and related terms related to earthquake and faults. If you like the video, please hit the like button, share it with your fellow aspirants, and subscribe to our channel for more such content. Thank you very much.